All right, folks. Now that we've talked about average variable costs, let's go back and compare that to average physical product. Now, if you remember, we talked about average physical product earlier in chapter 6. And what average physical product is output divided by input. So it shows us how much can we produce per unit of input. And what's interesting to note is that average variable cost and average physical product are actually mirror images of each other. They're basically showing along the same lines, or they're going to come up with roughly the same answers. They're going to look relatively the same, only the difference is they're going to show us two slightly different things. So, for example, average cost, average variable cost is actually going to show us it's going to look at the output per the cost of that output. What is the cost per unit of output? Whereas APP, average physical product, is going to show us how much are we producing per unit. And what we notice is that if you look at the way that this curve is shaped, the average physical product curve is shaped, it's actually shaped the same way. It's just flipped. It's just flipped over whenever we're talking about the average variable cost. And something else to notice is at the minimum point of the APP curve. So that maximum point of the APP curve is actually right here, right about 26 hours and 8.1 units of output. So at approximately 8.1 units of output and at 26 hours of labor, we have the maximum point of the average physical product. And even though this says maximum, at the minimum point, not maximum, but at the minimum point of the average variable cost curve, which is right about here, we're at 8.1 units of output, and over here at about $16. So if we look down here at this table, we can actually see it listed out in the numbers. So for example, we're looking at average physical product, and we're going to keep going down, and we see that average physical product peaks right here at this at an output of $8.10 and at a labor use of $26. Whereas average variable cost, it actually hits its trough, its bottom right here at the same point. So basically what that's telling us is that these two lines are going to mirror each other. They're just going to be flipped over. And that's an important concept. And the reason that that is an important concept is because this is actually showing us output per unit of labor. So as that output per unit of labor rises, and remember our average variable cost is equal to the total variable cost divided by output, and that our total variable cost is the number of inputs times the price per input. So as basically the output per unit of labor increases, as we are starting to produce more with the same amount of labor, as we can produce more with that same amount of labor, the average variable cost must fall. It must go down, because now we are basically spreading out the amount of our output over less variable costs. But as soon as we hit this peak in this average physical product curve, then our output per unit of labor, after we hit this peak, our output per unit of labor begins to fall. And as that falls, that means we're not accomplishing as much per unit. So if we're not accomplishing as much per unit, obviously our output per unit of variable cost is going to start increasing because we're not as efficient. And this actually has to deal with efficiency. Right here at this peak of this average variable cost curve, we're at the most efficient point in terms of per unit of input. And where we're most efficient is actually going to be the minimum point of this average variable cost curve. So essentially both of these graphs, they're mirror images of each other. In the average physical product curve, it shows us how much output per unit of input. Whereas this average variable cost curve is going to show us what does it cost on average per unit of output. And they tie together nicely simply because our average variable cost is basically a function of the number of inputs, this is what this is dealing with, the number of inputs and how much of an output are we going to get on average per unit of input. And basically, we're just putting dollars to it. And we're finding out that they're mirror images of each other, and that as time goes on, you're actually becoming more efficient up until this point. And that's what we're going to be moving on to next, is we're going to be talking about efficiency and how we can actually look at these average curves and discuss efficiency.